Chapter 5.6, Day 2, we're looking at inverses of functions. Here we're going to look at inverse of a quadratic function. So we're going to find the inverse of f of x equals x squared, and we have to take a look at when x is greater than or equal to 0. So the first thing to do is this is the same as when we were solving for inverses of linear equations. Our first step is always to set y equal to f of x. So change the f of x to a y equals x squared. Then we switch the roles of x and y, so just switch them, x, and then this becomes y, so x equals y squared. So we just switch the roles, whatever's happening to the x is now happening to the y. Now we're going to solve for this y value here. And so what we do, in order to get rid of that square, we square root both sides. So let me rewrite it, x equals y squared. To get rid of the square, you square root the y. Now remember, when you square root, what happens when you take the square root? When you square root, you get a plus or minus, and then the square root of x. So we need to go back. We're trying to take a look at what are we looking at the beginning. What are our restrictions? This is x squared, where x is greater than or equal to 0. So we're only looking at the positive side of this graph. So for example, if we're looking at this parabola, let's just graph it real quick. Oops. Graph it here. So this is the parabola x squared. And then now it says where x is greater than or equal to 0. So what that means is we only want this right side of the graph here, this one here. So what we need to do is we're going to go ahead and erase this left side. That's what it means by x has to be only greater than or equal to 0. So in our inverse function, when we're looking at it, we're looking at this here. We get plus or minus. Now, because we're only looking at the positive side of the parabola, that means we're only looking at the positive side of the square root. So therefore, if it's x is greater than 0, that is positive. Therefore, we're only looking at the positive in this case, okay, just to kind of emphasize that. So therefore, g of x equals a positive square root of x. So let's graph that so we can see, is it going to be an inverse? So square root of x, remember 0, 0, 1, 1, and then it is right 4 up 2, and here's the graph. Now remember previously we talked about that inverses are reflection off of the line y equals x, and this is definitely reflected over y equals x. Now, if we, for example, if we had left the left side of the graph here, notice that it would not be a mirror image of the radical form here. Okay, so just to kind of talk about that again. So let's go ahead and try the next example, find the inverse, and then we're going to graph it, and you're going to try graphing it. So now this is x squared minus 2, where x is greater than or equal to 0. So again, we're looking only at the positive side after we take this square root. So try this example, and then maybe try also number 5. All right, trying this out. So first of all, find the inverse of the function for number 4. So you change f of x to y, then you switch the roles of x and y, then you isolate the y, so we add 2 to both sides. So we get x plus 2 equals y squared, then we square root. Remember that when we get a square root, we get positive and negative. And so because it says x is greater than or equal to 0, we want only the positive side of the radical. So we're only taking the positive of this square root of x plus 2. So therefore the function, the inverse function, is g of x equals square root of x plus 2. Then when you graph, the f of x is here. So you get x squared minus 2. We graph that one, so it's shifted down 2, and we use the pattern. It's a half of the parabola, again on the positive side only. Then graphing this one, our g of x, that's shifted left 2. And then the pattern is up 1, right 1, up 1, right 3. And notice it hits right at that point, which is right on that line of reflection. Number 5 was a little bit challenging, so you had to take a look at, first of all, we're looking at x is less than or equal to 0, so therefore we're looking at the negative side of the graph, so negative x squared, so I graphed that right away. So here we're looking at the left side of the parabola, okay, so we're looking at the negative. So then we find the inverse, so y equals negative x squared, so f of x to y. You switch the roles of x and y. Then we divide it by negative 1 to get the y positive. So we need to do that first. Then we square root both sides. So it's a square root of negative x, and it's a plus or minus square root of negative x equals the square root of y squared. Okay, so when you see that happens, when you divide by negative 1, it's negative x here. Then we square root to get rid of that square. And then we have plus or minus. Now because it's minus, again, less than or equal to 0, we only want the negative side of this function. So therefore, it is g of x equals negative square root of negative x. So this is an interesting one because it's reflected across the x and reflected across the y. So first of all, reflection across the y. So let's look at the normal graph here. Reflected across the y-axis, that means it goes this direction. Then reflected across the x-axis is here, therefore it reflects down here. So that's why we get this graph, that blue graph here of g of x. Okay, so just the different reflections that's happening to that graph. So here is our graph for that, and so hopefully you could find that at least algebraically. And so let's try it with some cubics. We're only finding the inverse only. We don't need to graph these. So let me try one example here. F of x equals 2x cubed plus 1. We still do the same process. Set f of x to y, 2x cubed. Then we switch the roles of x and y. So x equals 2y, and then that's cubed plus 1. Now it's cubic, so we don't have to worry about signs. So let's go ahead and solve. So subtract 1 from both sides. We get x minus 1 equals 2y cubed. Then we divide by 2. So we get x minus 1 over 2 equals y cubed. To get rid of that cube, you cube root each side. So we've been doing this chapter. So now we get y equals a cube root of x minus 1 over 2. So really that's g of x equals cube root of x minus 1 over 2. And we're not going to go ahead, we're not going to rationalize it or anything. That is just fine. So what I want you to do is try these other two examples. It's the same process as you do with the linear. We're only thinking about cube rooting instead. So just find the inverse of each of these, number 4 and number 5. Hopefully you found the inverses of these functions. So for number 4, you set f of x to y, then you switch the roles of x and y, and then solve for y. So the first thing I do is add 2 to both sides, and I changed my numbers here, so let me change it back. So this is a positive 2 here, and then we divided by 3. So therefore we get x plus 2 over 3, and then we take the cube root of each side, and we get g of x equals the cube root of x plus 2 over 3. And again, don't rationalize. Number 5, we have y, we change f of x to y, and then we switch the roles of x and y, and notice the negative is still there. So we subtract 4 from both sides. We get x minus 4 equals negative y cubed. Divide by a negative 1, so we can make that y positive. And then I have this. And then I take the cube root of both sides. So we get g of x equals the cube root of negative x plus 4.